Saxon Algebra 2, Lesson 108. We are halfway to the end of the year from spring break. 3 more weeks to go. Yay! Today, we're dealing with something that is super practical, useful, and straightforward. This sum and difference of 2 cubes, I can best explain to you by saying it's a factoring method. And I hear you. I know what's happening in your brain right now. You're saying factoring method. What does that even mean? Why must my life include math? Okay, here's another factoring method you know. We call it difference of 2 squares. We learned it a long time ago. And what we learned is that if you have an expression that looks like this, it's something squared minus something else squared, you can factor that quickly and automatically. You don't even have to think about it. You follow this pattern, A minus B, A plus B. And I always say you can put the minus first or you can put the plus first. It doesn't matter as long as you have one of each. I notoriously do it different all the time. So there's no pattern, there's no method to my madness. So as long as there's 1 plus and 1 minus, you're fine. Difference of 2 squares is a factoring method. It's a way to factor something, and what's beautiful is we don't even have to think about it. As soon as we notice that pattern, difference means subtraction, 2 squares means both of these are squares, we can just do it. That's the same way that these two, we actually get 2 new factoring method. So this is the one we already know. Now let's do the sum of 2 cubes. Oh, I spelled it wrong. Cubes. That looks like this. Sum implies that we're adding. So it's A cubed plus B cubed. And then as soon as we recognize we have this is the automatic pattern that we can do. It's a little longer, it's a little more confusing, but it works in exactly the same way as difference of 2 squares. As soon as you recognize the pattern, boom, there it is. If you memorize this, it'll be super easy, right? And then the third of these similar kinds of factoring methods is the difference of 2 cubes. Notice that with cubes, we have a sum and a difference pattern. I'm going to number these. 1, 2, 3. You could flip these around if you wanted. It doesn't matter, but I'm just doing the addition first. Let me show you the third pattern. This is when you have a cube minus a cube. And what you do is factor it just like this. Okay, so these are our 2 new ones. That's our old one. They're all friends. They chill together. Let's look at what it's going to be like to memorize these 2, because you do have to memorize them, so you might as well just start now. So let me just show you some interesting things. In the first binomials, we both just have a single A and a single B. Notice that the sign between them matches the original sign, okay? So this sign, and it goes up here as well, this sign matches. Now we get to this quantity. Notice it's A squared, AB, B squared, A squared, AB, B squared. Same pattern. Notice that this sign is the opposite sign. So let me draw an arrow. See, I'm trying to draw the arrow so it goes like all the way down here, right? This one is the opposite. And then this last sign, the one before the B plus, is always positive. When you notice this pattern or these patterns between the 2, it makes the memorizing a lot easier. In the first binomial, it matches. In the big part, the trinomial, it's the opposite and then it's plus. The opposite and then it's plus. All right? That's a little memorization help. Let's go on and look at a mere 3 examples, my favorite number, and look at how we put this into practice. Ready? Example 108.1. John says factor, and then he gives us this expression. Okay, so we look at it and we go factor. I don't know how to factor that. And then you go, oh, look, this is a cube, this is a cube. That's a subtraction. That's a cube. That tells me we have a difference of 2 cubes. Difference mean we're subtracting. This is a perfect cube and this is a perfect cube. So let's get our formula in front of us. This is a great time to practice. It's minus, same sign, opposite sign, always plus. Okay, so there's our formula. That's helpful. Now, what we have to do is figure out in our problem, what is our a? What is the cube root of this first quantity? Well, the cube root of x cubed is x, and the cube root of y cubed is y. Now let's look at our b, right? That's the second part. In our example, oh, it looks pretty much the same, right? This is a b and this is a p, so we'll know this is a single p. This is probably the hardest part of the whole problem, is you have to find the cube root of each of these quantities, and then you use this to fill in the formula. All right? So now all we have to do is use this pattern with these values. So let's write it out. A minus b, that's going to be xy minus p, times the quantity a squared, that would be x squared y squared, plus a times b, and I'm just going to write that in order rather than putting it alphabetical. That'll help you see the pattern. Plus b squared, well, b is equal to p, so that's p squared. Do you see how we take these values and plug them into this formula, and that gives us the factoring of this? And let me just triple check and make sure I got the right answer. xyp plus p squared. Good. Okay, this is right. I'm super paranoid because every once in a while, and it happened this week, somebody will reach out to me and point out that there's a mistake, a calculation error. A lot of times it's a mindless, it's like a copying error in my video, and it's so frustrating because there's no, I think of, oh my gosh, how many students have watched it and been confused? Okay, that's the right answer. That's all we have to do. So you see, there's not a lot of work to this. We recognize the pattern, we write down the formula, and then we identify our values. What is our A, what is our B, and then we just fill in the blanks. The math in this is not too hard. Let's try another one. John says factor, oh my gosh, and then he's got a big thing here. I'm gonna write it on its own row. X m to the third, y to the sixth, plus x third. Okay, this b looks really nice, but holy smokes, we're gonna have to find the cube of all of those. All right, we can do it, not a problem, but now we need the sum of 2 cubes. So this formula isn't gonna work, we have to remember the other one. So it's a cubed plus b cubed equals, first we have the little quantity with the same sign, then we square this, and we have the opposite sign. That's a minus, sorry. AB, always positive, b squared, okay? That's a negative. I'm just gonna write minus there because that looks really confusing, doesn't it? Okay, now we find what's our A and what's our B. Okay, so we have to find the cube root of this. We just go down the line. What's the cube root of 8? Oh, 2 cubed is 8, so that's 2. What's the cube root of m to the third? Well, that would be 1, so it would be just a plain m. And then what about this? Well, if we divide this by 3, we'll get the right answer. It's y squared. Okay, so that was a little step-by-steppy. Then you can double check your answer by cubing each of these. 2 cubed is 8, m cubed would be m cubed, and then this cubed would be 3 times 2, right? Because when we raise a power to a higher power, we multiply, and that would give us the 6 back. Okay, this is just x. Ready? Now we're gonna do this with these. Okay, so our first one is a is 2my squared plus x. Then a squared, we have to square this. Okay, so 2 squared is 4. M squared is m squared. Sounds like I'm talking in riddles, doesn't it? And y squared, again, think of it as it's y squared raised to the higher power of 2, and we multiply those, it's 4. Y to the 4th. And then this, so this is how we thought about this. There. It's a thought bubble. Okay, and then minus a times b. Again, I think it's helpful if I don't alphabetize it. I just write it in order so you can see, oh yeah, it's just both of them. Plus b squared, our b is x. So that's x squared. Let me double check. Make sure I got it right. 2my squared plus x, quantity 4m squared y to the 4th minus 2my squared x plus x squared. Yay! I don't worry about getting problems wrong. Like, I don't think it's bad for the teacher to get one wrong because teachers are human beings, right? And everyone gets math problems wrong from time to time. I don't have any, there's no shame in that. The only reason I hate getting problems wrong in videos is because there's no conversation, right? If you could stop me and say, wait, did you really mean that 2 times 6 is 4? And I would say, oh my gosh, thank you. But there's no way to stop it. And then students second guess themselves and wonder if they're crazy. It's a mess. So I'm sorry if I'm making mistakes. I don't want to. Ready? 108.3, our last one. And that problem is factor a to the 12th plus b to the 12th. It's a really big exponent, okay? So let's get our factoring pattern. We know this is a sum of 2 cubes. We know that these are cubes because this number is divisible by 3. Remember, that's the secret for breaking this down is it divisible by 3? Yes, it is. If the answer is yes, then it's a cube. Okay, so that's a quick way you can test that. All right, let's write down our formula first. A cubed plus b cubed equals, this is a little baby version, and then a squared minus ab plus b squared. Okay, we've got our formula. Now, we have to break these down into the cubes. I told you this rule. Here's another way that you can look at this. If you're feeling confused about how do I break this down, this literally means a times itself 12 times. I'm gonna write 12 a's in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You just did it too. This stands for this, right? A cube means 3 equal groups. So the question is, can we divide all these 12 A's into 3 equal groups? Yes, there's going to be 4 in each one, right? There's one set of A's. Here's another set of A's. And here's a third set of A's. So we can see that our A value, as we use it in our formula, in this specific example is equal A to the 4th. It's kind of confusing that these are the same letters as these. In our other examples, they use different letters. So don't let that mess you up. But this is the formula. In order to use the formula, we need to find the cube root of our first term, and that is a to the fourth. So our value for a will be a to the fourth, and b, don't worry, we don't have to write b 12 times. I'm hoping you wrote it out 12 times too, but we don't have to do our b 12 times. That we understand. You just divide it by 3, right? There's our rule. And that becomes b to the fourth. 12 divided by 3 is 4. Okay, now these are the values we're going to use to write this out. So it's going to be a to the fourth plus b to the fourth times a squared. That means it's like a to the fourth raised to the second power. We use the power rule. This becomes a to the eighth minus a times b, a to the fourth, b to the fourth, plus b squared, that's b to the eighth. That's our answer. Let me double check. A to the fourth plus b to the fourth times quantity a to the eighth minus ab 40 plus b to the eighth. Yay, that's right. If you ever see me make a mistake in a video, I would love it if you emailed me. I'm obsessed with this, aren't I? I can't stop talking about it today. No, I just want to be able to check and fix them. And then what I'm going to start doing is I'm going to write in the description to the video, like the solution to example 103 should be 47 or whatever, right? Usually it's a tiny little difference. Like the one that I saw was that the answer should have been m equals 25 over 4, and I calculated it correctly. But when I got to the answer, I wrote m equals 25, and I did this. And my students go, what happened to the 4? Oh, dang, you're right. I just wrote it wrong. This is the right answer, but I wrote it wrong. But I only know that because she emailed me and said, why did the divided by 4 just go away? Do you see what I'm saying? So if you think I messed it up, please email me and say, I think you messed it up, so I can fix it. Okay, guess what? Lesson 108 is not messed up. Lesson 108 is done. Congratulations. We have 3 more weeks to go. Yay, goodbye.